Hey guys, I hope you all are doing good. Today we're going to be starting with sequences, which is the next topic of discrete math. I haven't been posting in a while. I've been busy with my final semester going on, and I'm also working on my startup. So been super busy, but finally all my submissions are done pretty much. So I'm going to be completing the discrete math series. Whatever we covered so far until lecture 29th was pretty much the first half of discrete math, and now we will be covering the second half, which will be sequences, graphs, all the way up to connectivity, Euler graphs and stuff, right? So in this lecture, we will be starting with sequences and sums, right? So it is basically an ordered list of elements where order matters. So the simple point is that we're just organizing data in a sequence. If you remember, we used to have sets, and in sets, the order in the sets or order did not matter, right? So that's one very important point to note. However, in sequences, the order is super important, right? So this is the simple notation. You have an, where an is the nth term, right? So I'll try to give you, over here, I have the examples. So for now, all you need to understand is that sequence is an ordered list of elements, which is that they're going or increasing or decreasing or some sort of a sequence going on where the order matters. Second thing is that this is the notation where we kind of represent it as an in general, and an is the nth term. So for an example, we can say that a1 for something could be, let's say 2, a2 could be 5, a3 could be, let's say 8, right? Okay, let's try to understand something very important. So this n is usually like a natural number. Basically what happens is that you start with n equal 1 and you keep on going, n equal 2, n equal 3, etc., etc., right? Okay, so over here I have a few examples. Now let me show you what exactly they mean. Let's say, for example, one of the terms is an equal to n, right? This is, let's say, a representation of a sequence of what's happening in the sequence, right? So if you look at this carefully, right, this is kind of just like a function. If I input, let's say, a1, it says an term is equal to 2 multiplied by the number n. So if I look at a1, it should be 2 multiplied by the number 1, which is 2, right? The second term, a2, should be 2 multiplied by the number 2, which is going to be 4. And a3 would be 2 multiplied by 3, which is going to be 6. So if you look at the sequence, right, this sequence over here where an is equal to 2n is basically all the even numbers, and you're going 2, 4, 6, 8, 10, 12, right? That's what the sequence is kind of displaying. And let's look at the second one now. In the second one, it says an is equal to n, right? So if I look at a1, a1 would simply be 1, a2 would simply be 2, a3 would simply be 3. So this is just basic number. We can say natural numbers keep going on, and we're just going on from like 1, 2, 3, 4, 5, 6 until the very end, right? Now, these two were just very simple sequences, I should say. The third one is pretty interesting one, right? So if you look at this, it says an is basically equal to -1 to the power of n, right? Now, just for clarity, let's say -1. If it's just to the power of 1, it would be -1. But if it's something at the power of, let's say, even, right? Let's say if it's 2, then that would mean that we are doing -1 multiplied by -1, right? Which would result in a 1. So the important point to note is, if the power is, I should say, if the power is an even number, then that would result in all the minuses being cut out and resulting in a positive number. So let's say if we have a1, a1 would be -1 to the power of 1, which would simply be -1. a2 would be -1 to the power of 2. In this case, it would be 1. Now, if you look at the third again, a3 would be -1 to the power of 3, which would be -1 again. Okay, I want you guys to try to pause the video and just take a look at the sequence over here, like understand the pattern that's happening, right? Okay, so I hope you try to pause the video. If you look at this carefully, right, what's happening is that first element is -1, second is 1, third is -1. And if you look at this pattern is kind of going like -1, 1, -1, 1. So it keeps going in that direction, right? This is a very important point to note that sequences also kind of have this pattern recognition problem. So a lot of the tests or exams or even in interviews, you might be asked to understand patterns and find out what the pattern of a certain sequence of numbers is, right? So this is kind of very important sort of concept to understand, right? Okay, so that's pretty much what the sequences is. I'll give a quick summary. One only important thing that you need to understand in the very basics is it's a sequence of elements. The notation is an, and you basically say something like an is equal to 2n. This 2n or this n, whatever this is kind of representing what the function is, what the sequence is when you input the value, I should say n, right? Okay. Now, why is it important to understand again? Look, sequences are pretty much involved in our life, right? There are a lot of concepts that involve sequences. If you're coding or if you're doing certain tasks, sequences are definitely involved. One of the examples would be, let's say, a stock price over time. As stock increases, it's kind of going in a sequence in the right direction. I should say, in the future, it keeps on growing or maybe decreasing. Another example I can say could be algorithms, right? So these are the basic examples of algorithms, right? Now, moving on, let's understand increasing and decreasing. Okay, guys, now let's try to understand increasing and decreasing sequences, right? This is a very simple concept to understand. Once again, if you've probably covered them so far in your lectures or anything where you're learning, that's fine. What I personally do is that whenever I'm preparing for exams or just in general learning, I would play this video at like 1.5x speed or 2x if I'm learning from some YouTube page. And I would just start making sure I understand everything and keep making notes if I feel like I don't understand any concept, right? So that's my entire point, right? If you're someone who doesn't understand the concepts, then it's better you just watch the video at 1x speed. If you're someone that already knows the concepts, just speed it up and just make sure you are understanding and you've already covered the concepts, right? Okay, so increasing and decreasing sequences. These are very simple concepts. First of all, let's take a look at increasing sequences, right? From the word itself, you can easily kind of understand that the sequence is increasing, right? Meaning it just keeps on increasing, the value of the numbers keeps on increasing, right? So this is just the notation of it. This is just an important point to understand. It says the value an is actually less than an plus 1. What this in very simple terms means is, let's say I have a value a1, let's say a1 is 1, then a2 is 2. Over here, if you look at this, right, 1 is less than 2, right? So if you look at this, 1 is a1, this 2 is a2, this 3 is a3, this 4 is a4, right? Point is, an, one value would always be less than its next value, right? And this would be less than an plus 2, right? So over here, I've written the point that this is strictly less. Now, strictly less basically means that in the sequence, one number or one element, I should say, in the sequence would always be strictly less than its next one, right? They can't be equal, they can't be decreasing. They always have to keep on increasing strictly, right? So for an example, let's say, so if you look at this one, right, this is a correct sequence. This is a correct increasing sequence, right? But if I made a small change, let's say I made the change of changing this to, let's say, 3. Now this would no longer be increasing. It would be actually none of these possible types, right? Because I kept on increasing 1, 2, 3, 4, and then I decreased again. So it's not increasing, it is not decreasing, and it's neither any of these. Now let's say I changed it to 1, 2, 3, 4, 4. Again, this would not be increasing now because I want my sequence to be strictly increasing for this increasing type, right? So once again, very simple to understand. Increasing sequence is the type where it's strictly increasing, meaning an, a certain value in a sequence, is always less than its next one, which is going to be an plus 1, right? Okay. Next one is the decreasing one. This is again very simple to understand. It says an is greater than an plus 1, meaning this value in the current sequence would always be greater than its next value, right? So if you look at this, it's basically saying that, okay, the values are keep decreasing, and it keeps on decreasing strictly, meaning you wouldn't be at any point where the values are equal or they start increasing. They're always strictly decreasing, right? So I've given this example over here. So the example is the first value is 1 by 1, second is 1 by 2. Try to pause the video and try to figure out what exactly this an equal function should be. Okay, so the function over here would be an equal 1 by n, right? So if you look at this, this 1 by 1 would be a1, this would be a2, this would be a3. Now if you look at this carefully, right, a3 is less than a2, a2 is less than a1, and a4 is less than a3, right? So an is always greater than an plus 1 because we're pretty much dividing by 1 by 3 and keep on increasing the element in the denominator, right? That's why it keeps on decreasing in its value. Okay, so once again, this is strictly decreasing, meaning an is always greater than an plus 1, right? Now, the next ones are kind of maybe tricky to understand, but again, they're very simple concepts. Non-decreasing is just very simple word that you have to keep in mind, right? Non-decreasing means that it keeps on increasing or the elements could stay equal, but they would never decrease, right? This is the very simple point to understand. It's just kind of like, if you think about it like a graph, this is a graph going up for non-decreasing. It keeps going up, it could stay stable, it could keep on going up, stay stable. Like it could go flat, it could keep going up, it could go flat, it could keep going up. But the only thing that wouldn't happen in non-decreasing is that it would never go down, right? So once again, the point is simple. The elements keep on increasing or staying the same in the sequence, but they would never decrease, right? So this again, this notation is just saying that point that an, a certain value could be less than its next value or they could be the same value, right? So pretty much the example is, let's say first one, a1 is 1, a2 is 2, a3 is also 2, a4 is 3, right? So if you look at this, a2 and a3 are same, right? a1 and a2 have the difference that they increased. And then from a4 to a5, they stay the same again, right? So only simple point, they can be equal. The only thing that is not happening is they're not going to decrease. Same thing for the non-increasing one. It's very simple to understand from the word itself. It is not going to increase, right? So for this one, the graph is either going down, staying flat, going down again, but it would never go up, right? This is not going to happen, right? So pretty much keeps going down or staying the same, but never going up for non-increasing, right? So once again, this is the notation. An is greater than equal to an plus 1, right? So this is just very basic concept to understand. So for an example, you can be given a certain sequence, or maybe you're given an example and you're supposed to figure out, in this situation, do you think the sequence would be increasing, would be decreasing, or would it be any of these two? Like, would it be non-decreasing or non-increasing, right? So a very simple concepts to understand. Now let's move on to the more important topic, which is going to be arithmetic progressions and geometric progressions. Okay guys, now let's try to understand arithmetic progression and geometric progression. Very important concepts to understand. Can be a bit tricky, but they're mostly very simple to understand, I would say. There are just a few things that you should keep in mind, right? Always you should know these concepts. Okay, let's start with arithmetic progression. In the sequence, we start with some value a and keep on adding some number d each time, right? So progression is basically you're progressing, right? Arithmetic progression would mean what I do is I start with a certain number, a certain value, which is going to be my starting value. We call it, let's say, a. And what we do is we keep on adding some number d each time to it. And that would be known as arithmetic progression, right? Okay. So basic example would be, let's say 1. Let's say I start with 1. I keep on adding 2 to it. What would happen is I would have the sequence 1, next would be 3, next would be 5, next would be 7, 9, and it would keep on increasing, right? In very simple terms, I started with the number 1, right? And I keep on adding 2 to it. This is one of the examples of arithmetic progression, right? Okay, so that's the basic understanding of it. The form is pretty much like this. You start with A, you add this element D, second you add it again, you add it again. So if you look at this carefully, right? First I had A, second time I had 1D, I added D again, so you can represent it as A plus 2D, and third time you can represent it as A plus 3D. Again, keep going on and it will have A plus 4D, A plus 5D again and again, right? This is what you call arithmetic progression. Now, general term, now this might seem confusing, but it is very simple to understand. The simple point is that any term an in the sequence is simply the first value, whatever the first value I had, plus n minus 1 times the value d, right? So if you look at the general form as well, right? First I had a, right? The first one. Second time I had a plus d. So if you look at a2, right? It would be a plus n minus 1, which is 1 times d. Third element would be again a3 equal a plus n minus 1. So n minus 1 in this case would be 3, since this is the third term, 3 minus 1, 2 times d, right? So this keeps on going. So this is just a general form, meaning is this is the first term, and the next term is you multiply d by n minus 1 times, which is the general form of a arithmetic progression, right? So I've given these 3 examples over here. So in the first example, let's say 3, 7, 11, 15, and 19, right? So if you look at this carefully, right, the first element in this case is 3. This is going to be array. And now let's try to analyze what's happening, right? I started with 3, went to 7, went to 11, went to 15, right? Now if you look at this carefully, right, if you subtract it, you'll find that we are basically adding a plus 4 each time, right? We keep on adding plus 4. So in this case, our a would be 3 and the value of d would be 4, right? This is like very simple to understand. In each single case, we keep on adding d, right? So in the first case, we added 1, 4. Second, we added plus 4 again, plus 4 again, plus 4 again. So it keeps on multiplying d by a certain number. Okay. Second example, if you look at this carefully, we started with 100, but this time the values are decreasing, right? It went to from 100 to 93, 86, 79. So in this case, what's happening is my a term would stay 100, right? But the d is negative 7, right? Why? Because I keep on decreasing my progression by a value, right? Now, progression in this arithmetic progression doesn't mean that it has to be increasing sequence. It is just that we have certain value a and we keep on adding a certain value d. Now that d value could be negative, positive, or anything else, right? That's the important part to understand. So in this case, the a is 100 and d is negative 7, right? In the last case, let's take a look at the last case. So I've given the sequence over here, right? But if you look at this carefully, it's literally nothing is happening, right? It's just 5, 5, 5, 5, right? So I want you guys to try to pause the video and try to figure out what is the a value and the d value in this case. Okay, so in this case, the a again is the a value is very simple to understand. It's simply just the first value that you started with, which is going to be 5, right? And in this case, the d value is what is the common difference between them, right? D is basically the common difference. So if you look at this carefully, right, there is no difference, right? It just stays the constant value, meaning the d value in this case, the common difference would be basically 0, right? So this is a arithmetic progression is very simple to understand. One of the questions could be you're given a sequence and you're asked to find the value a, and maybe you're also asked to find the value d, or maybe you could be given a general example and maybe you're supposed to find what is the formula for that arithmetic progression, right? So once again, you start with the value a, you keep on adding a certain value d, which is called the common difference. The form is a, then second time a plus the common difference, 2 times the common difference, 3 times it, and the general term is what I've described over here, right? Very simple to understand. Now, one of the examples of arithmetic progression in real life would be, let's say you are saving some money, right? So let's say I keep on adding $200 to my bank account every single month. That is a sort of arithmetic progression, right? let's say I start with 0, that would be the A value, and let's say I keep on adding 200. So that 200 would be the common difference, right? That would be the D value in that case. Okay, so now let's try to understand geometric progression. This is again a very important concept to understand, and then I'll try to give examples of how it relates to real life, right? So in the sequence, we start with A and keep on multiplying by the same number R each time, right? Now, I need you guys to understand a very important difference in geometric and arithmetic progression. In arithmetic progression, you were adding a certain value, which is called the common difference, represented by D each time. In geometric progression, you're multiplying the value A by a certain number R every single time, right? This is the very simple difference, right? But you should have the clarity in your mind. Okay, so the form is started with A multiplied by R, then 2 times R to the power of 2, R to the power of 3, R to the power of 4. So every single time I keep on multiplying by the value R, starting with the A, right? So A multiplied by R, R again, keep going on, right? And the general term, if you look at this carefully, AN is basically the value A, the first value we started with, multiplied by R to the power of N minus 1, right? Once again, I hope this is very clear why we have this general term. You can try to pause the video and just try to figure out why exactly, right? I'll give you like a hint in this case too. So this is A1, this is A2, this is A3, A4, A5. So why is this general term? Start with A1. Over here, I have just A, right? A2, I have R one time. When A is, so when A is 3, R to the power is 2, right? When A is 4, R to the power is 3. So it's pretty much the value A, and R is a value N to the power of N minus 1, right? Okay, I've given 2 examples. I've given 3 examples over here, very important examples to understand. So starting with the first one, I start with the value 2, keeps on increasing 6, 18, 54, right? So this is very simple to understand. The first value in this case is 2, which is very simple. The R value is 3 in this case, right? And how is that possible? So if you look at this, right, I started with 2, I multiplied it by 3, which gives me 6, right? Multiply it by 3 again, gives you 18. Multiply by 3 again, gives you 54. So every single time you're multiplying by this value 3, and that's how you get the value R equal 3, right? Okay, in the second example, now this is where I want you guys to find out what the R value is. If you look at this carefully, right, I started with the value 2, but then it decreased to 1, then it kept on decreasing to 1 by 2, then 1 by 4, right? So try to pause the video and figure out what exactly is happening in this case. Okay, so if you think about this, right, went from 2 to 1 to 1 by 2 to 1 by 4. The R in this case would simply be 1 divided by 2. Why? Because if you think about this, right, I started with 2, multiply 2 by 1 by 2 gives you 1, multiply 1 by 2 again gives you 1 by 2, and then multiply it by 1 by 2 again gives you 1 by 4, right? So very simple to understand. But one important distinction that you need to understand is, right, over here, the growth is exponential, right? If I keep on multiplying example 1 by 3 again and again, it is growing very exponentially, right? In the example 2, I keep on multiplying it by a decimal, I should say, right? Like a fraction. And it's kind of going down, or I should say decaying pretty much, right? In the third example, once again, I would like you guys to pause the video and try to figure out what the R value should be in this case again. Okay, so in this case, once again, starting value, this is going to be A. But if you look at this, we went from 3 to minus 6 to 12 again to minus 24. So the problem is that this is not just increasing, but it's also the signs keep on changing. They keep on fluctuating from minus to positive, right? So over here, the very simple thing would be, if you try to figure out, we're multiplying it by minus 2 every single time, right? So if you multiply 3 by minus 2, we get minus 6. Multiply minus 6 by minus 2 again, the minus signs cut off and gives you positive 12. Multiply 12 by minus 2 again, gives you minus 24. So in this case, when you're multiplying it by a minus number, a negative number, it keeps on fluctuating, going from negative to positive, right? Because of the negative number R value. So in this case, R value is -2. Now, the reason I've chosen these specific examples is because of the pretty much, I should say, the importance of these examples. Example 1 is showing that there's exponential growth when the R value is greater than 1, right? So I'll try to note this down. So if R greater than 1, exponential. So in geometric progression, if the R value is greater than 1, the progression would be exponential growth. The graph would look kind of like this. It would keep on increasing in an exponential way, right? In the second example, I showed you that it is decaying, right? When you multiply it by a fraction, it keeps on decaying again and again. Okay, so what's happening is, the important point to understand is, if the value R is greater than 0 but less than 1, then in that case, it is going to decay. Meaning it's pretty much slowly going down and down again, right? In this case, we keep on basically making it half of every single time. So we divided half 2 by 2, giving us 1. Divided 1 by 2 again, giving us half, then 1 by 4. So it keeps on decaying in a certain way, right? And so pretty much, if R is a certain value which lies between 0 and 1, then it is going to decay, right? And the third one is pretty much what happens if you multiply by a negative value, right? So if you multiply by a negative value, R is, let's say, less than, I should say, 0, then it keeps on fluctuating. Positive, negative, right? Okay, so this is the exact reason I wanted to show these examples, because you should keep that in mind. Like, you should know if R is greater than 1, then there would be exponential growth. If R is between 0 and 1, there would be a decay. And if it's less than 0, which is, if it is a negative number, then there would be a fluctuation going from positive to negative. This is like just like an important point to keep in your mind, right? Okay, so once again, just a quick summary of arithmetic and geometric progression. Arithmetic progression, you just keep on starting with the number value A. You keep on adding a certain value D, which is called the common difference, every single time. In geometric progression, you're not adding, you keep on multiplying a certain number, which we call R, right? Form and general term I've given, and there are a few examples on the board as well. Okay guys, this is the final part, and after this I'll give you some practice problems. Try to pause the video and solve those questions, and then I'll give the answers on the board, right? So this is again a very important concept to understand. This is the type of question that you could be getting. And not just that, in coding in itself, if you are from a technical background or if you are in computer science, finding the rule for a sequence is kind of a very important task, right? In a lot of coding problems that you're trying to solve or you might come across, you're trying to find a sequence or kind of a way to go through that sequence, right? So very important to understand, a lot of lead code problems are also kind of based on finding a sequence kind of concept. So the more problems you will solve, the more you'll understand what I'm trying to say. But very important to understand, right? So given the first few terms, we are supposed to find an, and it is not always arithmetic or geometric progression. So the point is very simple, right? What happens is you're given the sequence and you're asked to find what is the rule for it, right? How do you keep on building the sequence? Like, what's the general pattern that you can keep on noting, right? So one of the examples is, if you look at this one, right? 1, 4, 9, 16, 25. So if you look at this carefully, right? The first term is 1, second is 4, seems to be like the square of 2. Third is 9, which is the square of 3. 4 is 16, which seems to be square of 4. So it's pretty much first term is 1 square, second is 2 square, 3 square, 4 square, 5 square. So what is the general pattern? General pattern is the term an will be the value n to the square, right? So this is the general pattern in this case. Once again, the sequence could be anything, right? It could be probably, maybe it's an arithmetic progression, or maybe it is a geometric progression. It's just not necessary that it would be one of these two, right? It could be anything, and one of the examples is over here that I've given, right? One very important sequence that I think you've probably heard of is the Fibonacci sequence, and it is a recurrence relation, right? We will cover recurrence relation in the upcoming lectures, but if let's try to understand the Fibonacci sequence for now, right? We'll cover the recurrence relation definitions and stuff in the future. So the point is very simple. If you look at this carefully, right, I start with the value 1, then 1, it became 2, then 3, then 5, 8, 13, right? Like if you look at it, it might not make any sense in the beginning. You might be trying to figure out, okay, it doesn't seem to be like anything is happening, right? But if you look at it carefully, right, every single term seems to be the sum of the previous two, right? Except the first two. So the third term 2 is the sum of 1, the first term, and the second term. 3 over here is the sum of 2, and it is also the sum of 1. 5 is the sum of 3, and it is also sum of 2. 8 is the sum of 5 and 3, right? So if you look at the sequence, right, this is the general formula for the Fibonacci sequence. For a certain value, an is going to be equal to an minus 1, one previous value, plus the next previous value. So the previous two values added together would give the next term in this case, right? Okay. Now in this case, we also have the base, right? Since the formula in itself asks that we sum up the previous two, we need to have a starting point, right? And the starting point, we need two elements for the base, right? If let's say I didn't have the a2, then it wouldn't make sense, right? Because the formula in itself says it is an minus 1 plus an minus 2. So how do I find out a2? I've not been given any value for it, right? So that's why for the base, you have already been given two values, and you keep on building on top of the 1 ones, which goes to 2, 3, 5, 8, and 13, right? So finding the rule for a sequence is important to understand. There is no general way, or you can just find sequences, or there's no proper formula for it. But it's just that the more problems that you would try to solve again and again, the better you would get at understanding it, right? So, but the basic point is that you should understand these few things, like what is arithmetic progression, geometric progression. Like you should be able to grab these patterns easily when you see them in the exam or any sort of a problem you're trying to solve. And you should be able to know what is a Fibonacci sequence, or what is this pattern going on, the square pattern or a square root pattern, right? Okay, now one very important thing to understand is don't just assume whatever rule you might be, right? Make sure that you are very certain of the rule. And what I mean by that is, in certain cases, you might see a sequence and you might make the assumption that, let's say, the an would be a certain thing, right? The problem is that in a lot of the cases, you might try to make a general formula. It might work until a certain point, let's say up to 5 terms, but it doesn't work after that, right? So that's why, if you remember, we covered proofs and we covered induction, proof by induction, and proof by strong induction, proof by weak induction, which was to prove that if a certain sequence is actually correct or not, right? So in general, if you make a formula for something, you also have to prove it to showcase that, okay, this is going to be the correct one. But in general, smaller cases like Fibonacci sequence, or we have AP or GP, we don't have to prove those parts. But if you're trying to build a new rule for some new type of sequence that you're trying to note, then you can't just be like, okay, I'm sure that this rule follows the first 5 things. You also need to showcase that it would follow for infinity, right? I'll try to give an animation of one of the very interesting examples after this point. Okay guys, I've given 4 questions on the board, so you guys can pause the video and try to solve all these questions. Okay, so I hope you guys have solved these questions. Let's try to take a look at all of them one by one, right? So is an equal 3n minus 5 arithmetic or geometric progression, right? Now, the simple way that you can solve this question is simply by replacing n with the value and then substituting it, pretty much. So what I'll do is I'll try to find a1 is equal to 3, 1 minus 5, a2 equal 3, 2 minus 5, a3 equal 3, 3 minus 5. So this first term would be 3 minus 5 minus 2. This is going to be 6 minus 5, which is going to be 1. This is going to be 9 minus 5, which is going to be 4, right? From this, I think pretty much just from these three terms, it becomes clear that you're pretty much adding a 3 every single time, right? And since you're adding 3 every single time, it's pretty much going to be a arithmetic progression because we are adding a number, right? Moving on, find an for the sequence. So the sequence is 5, 15, 45, 135, right? If you look at this carefully, right, what I'm doing is 5, how can we relate it to 15? It relates because if I multiply 5 by the value 3, it results in 15. If I multiply 15 by 3 again, gives 45. 45 multiplied by 3 again gives 135, right? So what is this is going to be? This is pretty much the geometric progression. But the question is asking for the an. What is going to be the formula for this question, right? So I already know the value a equal 5, right? I know the value r is going to be 3 in this case, right? And an, if you remember, an is usually a multiplied by r to the power of n minus 1. So it's going to be 5, r over here is 3 to the power of n minus 1, right? I hope that makes sense. Okay, moving on. Now, the third and fourth one are kind of tricky to understand. So the fifth term of a sequence is given and its 12th term is also given, and we are supposed to find a and d, right? So the fifth term of a sequence is 23 and the 12th term of a sequence is 58. Find a and d. Now this is where those formulas that we covered for geometric and arithmetic progression come in play, right? Okay, so if you remember, the formula for arithmetic progression was a plus n minus 1 d. An is equal to a plus n minus 1 d, right? So if you look at this case, right, fifth term is 23, so a5 is equal to a plus n minus 1, which is going to be 4d, which is going to be 23, and a12 is going to be a plus 11d equal 58. Okay, so you have two formulas over here. Now this is where the interesting part comes in. I'll simply just subtract this equation from this equation, right? Leaving me with 5d equal 58, 23, 5, 3, 35, and this gives me d equal 7, right? Very simple to understand. So now I already have d. Now I need to find a as well, right? So I've been given an is equal a plus n minus 1, 7, right? Multiplied by 7. So I consider, let's say, consider the sequence numbers 5. a5 is equal to a plus 4 multiplied by 7, which is equal to 23. And you can pretty much find the value of a by subtracting this, right? Now, moving on, let's try to understand the last question. A geometric sequence has a3 equal 20 and a6 equal 540. Find r and a, right? Once again, I'm going to use the formula for the geometric progression. I know an is equal to a multiplied by r to the power of n minus 1, right? Okay, so a3 is going to be a multiplied by r to the power of n minus 1, which is going to be 2, which is going to be 20 in this case. a6 is going to be a multiplied by r to the power of 5, which is going to be 540 in this case. What I'm going to do is, in this case, in arithmetic progressions case, I simply subtracted one equation. In this one, I'll just divide the first, this equation by this equation, right? So what I get is 540 by 20 is equal to ar to the power of 5 divided by ar to the power of 2. This gives me a3 equal 540 by 20. Now, if you calculate this, this comes down, I should say, this gives r is equal to 3 in this case. Now, when you find r, now if we already find r, using this, substituting this back into the equation again, you can find the value of a as well, right? So that's pretty much it for this lecture. I hope you were able to understand everything about sequences, and we will move on in the next one.